Hey, thanks for watching. I'd like to show you my latest build before I send it to paint. This started out as the RCPowers Mig-29 version 4, and Scott Challenger and I have been working together, call ourselves a North American Mig Commission, to make this plane fly like the way we like to fly airplanes. A little more scale appearing, more scale flying, true rudders, and a little bit more responsive and a lot cleaner. So I'll go through some of the things that we've done and that I've done as well with this latest build. Once again, it's a hybrid build, so I use model plane foam for the fuselage. I find that I can sand it better and I can really fill in the gaps nicely, and it sands. I can get a nice clean finish, and I believe the plane goes faster, and also I get a lot less overall weight on the airplane. Same thing, the canopy as well as model plane foam. One thing I like to do on the canopy is when I glue it together, you can kind of see how it's a little bit narrow in the front. I bring the sides underneath the top piece rather than having out the side, then I go ahead and fill in everything as well. I have a full KF airfoil on this, KF top and bottom, and Scott and I have found that a full 40% flies a little bit nicer than 38 to 39%, which is the stock plans, and that's just simply by adding a 1/4 inch along the back side. Something else I'll go further over when I do a long build PowerPoint type presentation, but when I'm aligning my KFs up, I put a mark on the tip of the wing where I want the edges to line up. It helps me to really get them even top and bottom. So I've got a chisel bevel on the lurks, which then transitions at the wing root to a symmetrical airfoil rather than a chisel. And once again, this is something that Scott and I have found flies a lot nicer. On this plane with the version 4, the engine was moved a lot further forward, which made the carbon spar get moved further up as well. And I found that the wing was rather weak. I've used 4mm carbon spar, and then here you can just barely see. I've also got a 3mm carbon spar along the leading edge of the wing to make the wing even stronger. A few other things, just a few vent holes that we put top on the sides as well as the top. Other big change on this airplane, if you look at the vertical stabilizers, Scott increased these in size on his last build and found the plane really flew nicely with that. It also allowed us to have a nice large 4x2 rudder, and we have a true vertical rudder, which helps you control yaw, and you don't get a rolling pitching motion when you do rudder stall turns, knife edge turns, and other rudder type maneuvers. The biggest change on this airplane versus the stock is the modification of the elevons, and this is the second iteration. With the version 4, you now have a horizontal stabilizer in the front portion, which doesn't move, which adds a lot of stability, especially in high alpha and flight as well. And then these are our take on the elevons. They're more scale, they're much smaller in size, about 15%, and then we change the thrust vectoring area to increase a little bit of thrust vectoring control. Something else you notice as you look down the center of the airplane, we align our hinges to the inside so it's nice and flat, and all of the control arms and control horns are to the outside of the flow of the thrust off the propeller. Makes for a much cleaner flight. I'm going to turn the airplane upside down. Here you can see the way we mount the rudders. We call this outboard mounting of our rudders. Now I'm going to flip the plane over so I can show you what we're talking about. So here you can see the rudders line up in a row, and with the rudders you can see here, here's my elevons, my aileron, and then on the underside is the rudder. So they're all lined up, and the biggest reason I do this is so you can change your control horns. It's easy to get to if you want to control resolution on your servos. And the other thing that I found was I never liked having the elevon servos up here with the control arm running adjacent to the propeller, and you can never adjust it. Another thing you'll notice here is the position of the elevon servo is directly on top of the carbon spar. And this adds a lot of strength to the servo. You're not going to get any twisting or flexing in doing high-speed, large elevon type maneuvers. Something else I do on all my airplanes, you can see I've even filled in everything down in the fuselage. I fill in the nacelles, sand them down, shave them down. And even on the back side of the airplane here, I've rounded in the engine mount and filled that as well. You'll notice there's a lot of glass work on the airplane. Instead of using carbon spars, I'll go ahead and glass the inside of the vertical stabilizer for its strength. And then on the tail plate, in the past, I've noticed a lot of flexing. I used to use model plane foam on the tail plate, not anymore. I only use Depron. And the only place of model plane foam is on the fuselage. Everything else is Depron. But this is completely glass as well. And I use glass for my hinges. And then I go ahead as well and I glass the entire top surface of the elevon as well as the leading edge. And on the rudder here, you can see that I've glassed the leading edge of the rudder, and then the entire inside of the rudder is glassed as well. I use Aleene's tacky glue. It's very cheap, $2.99 a bottle, and it works nicely. And then I'm running a focal price 2700. Then I've got 8-channel servo. 8-channel receiver, and then running a Turnigy 40 amp ESC. One other thing I did on this plane, I plan on flying this plane with the NTM 2700 prop drive. So if you look in here, I use some carbon tube. And what I like about this is the carbon tube is directly glued, this is square tube, directly glued to the carbon spar. So that's going to be really strong. I've had with my NTM 2700 prop drive using the engine brake, which really allows for some really neat maneuvers. I've had where the engine mount actually pull off completely. So this plane is set up so I'll run it with the FP, the focal price 2700, and then I'm going to swap out to the NTM 2700 prop drive. I'm going to talk real briefly about control rods. I recycle my control rods, and from the version 3 to the version 4, they're all too short. And I was out of 2mm rod, so that's why I've got 3mm rod servos on the vertical stabilizers. And I like to use Z-bends, and I just used a little piece of Dubro rod to drill right through the control horn. So it's a nice tight fit. I find with the Cletus I get a lot of laxity. And then I use these linkage stoppers. And then on the bottom side, I've got a 3mm on the elevon, and then for the aileron I've just got a 2mm rod, and that's really the easiest setup. You can see the rod just goes right through the linkage stopper, and that's the quickest and easiest to use. And on the front side, I get some light on there. It's a Z-bend, and I also use a little bit of shrink tubing to hold the little wire Z-bend, which goes right into the control horn. One other thing I failed to mention was our inboard ailerons, and on a blog page we talk about why we like this so much, but real briefly, it helps prevent a lot of tip stalls, and really and truly with the elevons you don't need a whole lot of aileron. I utilize these a lot more as spoilerons and as flapperons, and on my video where I'll show you flying, I'll talk about my aileron on and off input to these, so I just have spoilers or flaps and only use ailerons. So, thank you very much.